Hi everyone and welcome to this video on sample spaces and probability. My name is Darren from Maths Guru. Thanks very much for stumbling across this video. Hopefully it is going to be helpful. It's actually part of the Methods 1 and 2 course here in Australia, but probability is worldwide. I can guarantee you that what I'm about to show you is going to be useful in every type of exam you're ever going to sit. In fact, what I'm going to show you is really a recap of year 9, and if that hasn't now seen you switch off, nothing will. Because obviously we build on in maths, and that foundational understanding really is important. Now, before I go any further, can you do me a favor? Nah, you've seen too many of these videos. I'm holding that for the moment. Have a look at the learning objectives. The learning objectives basically are there to say, well, is this what I'm going to cover by the end of the video? And also it's lifted from the Cambridge Mathematical Methods Unit 1 and 2 textbook. Thank you, Cambridge, so much for letting me use your examples. All of what I write now will be downloadable from Maths Guru behind me. Okay, so there's so much on there. There's all of these videos, downloadable lesson notes, summary books for general maths at the moment. I'm trying to work on one for methods, VCAA questions, and so much more. So head over there, absolutely free to sign up. Now, as I say here, we've been looking at probability since year 7. And to be honest with you, nothing really changes in year 11. When we get to Venn diagrams, that becomes a little bit more interesting. When we become to conditional probability, again, a little bit more interesting. But let's take this as the foundational stuff. If you're watching this, I promise you, I will try and explain it in an easy to understand way, using terminology and stuff you've already used before. All right, so should we get started? Absolutely, here's the terminology you need to know. And I suppose the one that becomes most interesting and most important is the idea of sample space, but more importantly, notation. Remember, methods is all about the notation, and that epsilon sign there is really important. And a sample space must be written in curly brackets, not square brackets, not round brackets. Remember now that means something very different in methods. Those square brackets, those curved brackets could mean a coordinate. If it's a curved bracket, it could equally mean an interval. And so the context of where you're using these is really important. So a sample space should be those curly braces. And a lot of people always say to me, what if I can't draw the curly braces properly? Don't worry about it. Examiners understand that, you know, what you're trying to do. I used to do silly things like that. Now I try and do a little bit more like that just because I'm older. All right, but again, when you get to Venn diagrams, really important you have that epsilon sign as well. A trial, basically just a single outcome, all right? A result from like one toss of a coin or a card you're picking from a deck, anything along those lines. Random experiments. Hopefully everything we're dealing with is going to be random, but who knows? We don't know. That's the whole point of probability, yes? So random is one that you cannot predict the results. Yeah, if I roll a sort of a standard die, I have no clue what number is going to come out. I know that I've got a choice of 1, 2, 3, 4, 5, and 6. I don't know specifically which one is going to come out. An event is a subset. Now that subset idea, this word of a subset, becomes a little bit more important as we move through this part of the course. Right, so basically it's a subset of a sample space. It can have more than one outcome. So for example, odd numbers from a standard die. Yeah, so we know that the outcomes of a standard die are 1, 2, 3, 4, 5, and 6. The odd numbers would be not 2, would be 1, 3, and 5, for example. That's a subset. And it's weird because the sum of all probabilities, and you're going to try and say, yeah, that's obvious, it's 1. But the number of times we get to methods 3 and 4, we do some of the probability questions, and students out there will answer, because they've believed their calculator, with a probability of 1.4. Yeah, I'll just leave that one there for a moment. A probability of 1.4. And again, the stress of the exam and not really thinking about what's going on. But if I ever got to a point that I wrote down a probability of 1.4, I'd probably want to go back and go, I don't think that's right. So here are some examples, right? Nice, beautiful examples that we're just going to work on. And what is important to me at this moment in time is, can you subscribe to my YouTube channel? That would be massive, all right? I think my last video got 54 views. And that surprises me because so many people out there go, oh, your content is awesome. But people dip in and they dip out. If you subscribe, it just shows me that you've watched. Turn off notifications if you never want to hear from me again. But just clicking that subscribe is massive. And today, believe it or not, I passed 10,000 subscribers. That was massive for me. And now everyone's like, 100,000. I don't think so. I think I'll be dead before then. So let's go. A bag contains 7 marbles, numbered 1 to 7, and a marble is withdrawn. Give the sample space for the experiment. Well, there we go. So here's part A. I'm going to write epsilon equals, and my curly braces, 1, 2, 3, 4, 5, 6, and 7. And again, you would have to argue, why are textbook publishers for a methods 1 and 2 course where we've gone from 1 minute we're doing the bisection method to something that's simple, putting it in, because we want you to trip up on notation. This whole course is about notation. The number of people who miss the basics, like the commas and the curly brackets and that epsilon sign, you're right, methods is a negatively marked course. And I'm going to stand by that, right? It's the only course where we actually knock marks off, right? So I'll give you a, for instance, if you draw a graph and you have this and you flick up at the end, you lose half a mark, right? That is my understanding. You lose half a mark and then they round it down. So if on a graph question you got 2.5 marks, they round it down to 2. So realistically speaking, you're losing a whole mark for that flick at the end, right? And there's so much more in my course that will tell you how to make sure you don't fall foul of VCAA's mark schemes and stuff. So there we go, nice and easy. Part B, what is that? List the outcomes, the elements of an event with marble with odd numbers. Sorry, try that one again. List the outcome, elements of an event. A marble with an odd number is withdrawn. All right, a marble with an odd number is drawn. So what do we do? So let's call this, oh, I don't know, outcome A. And again, I'm going to do curly braces. Why? Because it's a set of numbers, and a set of numbers have to have this curly brace. I want the odd ones. So we're going to have 1, 3. I don't know why I did that there. 5, and 7, and close my curly brace, and as far as I'm concerned, I've just smashed that very first question. Now again, normally they tell you in the question what the event or the outcome or the elements, will be actually called. I just called it A. It can be anything, but we notice again, what's really important is these things are actually capital letters, all right? So these are all the things that become important. Now, determining probabilities, again, this is year 7 stuff, but I think it's important to realize that we have been using this formula over and over and over and over again. Yes, that to find the probability of an event, you take the number of the event, so the number of things that are successes, and I would normally put successes there. The number of successes divide the number of elements in the total sample space, right? That's really, really important. Now again, not all probabilities are going to be equally likely, right? Now, when we throw a die, we could turn around and say, well, okay, they're all equally likely. But what if you have a biased die? Now, they are absolutely in existence. Coins, you would expect to have an equally likely outcome, a half and a half. But again, there are biased coins. So we need to be very careful when the question is giving us information as to what we're going to do. So, example 2, suppose a number is drawn at random from the numbers 7, 8, 9, 10, 11, 12, 13, and 14. What is the probability of choosing a prime number? Believe it or not, people don't know this. So I'm going to do the probability of prime. Now you'll notice if we go back here, the notation is PR and in brackets event. You have to write PR open bracket event. Later on in methods 3 and 4, be it specialists, be it methods, if you don't write down specifically what probability you're trying to find and have that, your marks are going to absolutely evaporate, and it would be a shame to have that happen. Right, what is a prime number? A prime number is one with only 2 factors. And again, that's really important. A lot of people go, oh, it's the number that's divided by 1 in itself. A prime number is one with only 2 factors. So let's see if we can list all the prime numbers there. 7, that seems to be 1. A lot of people choose 9. I don't know why. Probably because you go 1. What's the first prime number? 2, 3, 5, 7, and then I think you just get tricked into 9, but 9 is divisible by 3. 10, no. 11, yep. 12, no. 13, yes. So there we go. So what we're now doing is the number of successes. So that's 3. We got 3 prime numbers out of total of how many numbers did we have? 1, 2, 3, 4, 5, 6, 7, 8. Yep. And there we go, 8. So my probability of it being a prime number is 3 on 8 for that example. Again, relatively simple, yes? A random experiment may result in the outcomes of 1, 2, 3, or 4. So I'm going to write my outcomes there, 1, 2, 3, or 4. I'm going to write it in a table because, again, when we get a little bit later into methods, towards the end of the course, we get to a little bit more complicated stuff where we get x's and PR equals x. And so later on, you're going to have x, and you're going to have the probability of x equals x. I'm not going to worry about that too much at the moment. It's just a notational thing. But what they're saying is if these are my outcomes, 1, 2, 3, and 4, I'm now going to write my respective probabilities underneath. That's 1 on 13. What did that become? 2 on 13. and that's going to be 3 on 13. Find the probability of attaining a 4. So again, my notation is going to be PR4 equals what? And again, this is so fundamental simple, but again, a number of people don't realize that all of the probabilities given here must add to make 1. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I just use my fingers? I did. So that would have to be 7 on 13, because all of those individual probabilities, when added together, must give me 7 on 13, because I've exhausted my sample space with the numbers 1, 2, 3, and 4. Find the probability that each of the possible outcomes is observed for the following spinners. Now again, what do we notice? We've got 1, 2, 3, 4, and 5. Each of those numbers equal areas on that spinner. The number 1 doesn't appear more than once, 2 doesn't appear more than once. So in which case, the probability of getting a 1, 2, 3, 4, or 5 is going to be equal to 1 on 5. All right, so there we go. Find the probability that each of the possible outcomes is observed. So probability of getting 1, 2, 3, 4, or 5 is given by that. Then we get to part B. What do we notice? We've got 1, 1. How many 2s have I got? I've got 1, 2. How many 3s have I got? I've got 1, 3. So I've got one of those, and one of those. I've got a 4 and a 5. How many 4s have I got? I've got 2 4s. And I've got 1, 2, 3, 5. So how many slices have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, I'm just going to check because my brain plays tricks. 1, 2, 3, 4, 5, 6, 7, 8. Oops, that's awkward. So what's gone wrong there? 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. I can't count. That's the problem there. But I like the fact that I checked to make sure that it actually all added up. Right, so now what have we got? Well, then we got the probability of a 1, 2, or 3 is going to be what? Well, 1 out of 8. Yeah, because there's 8 sections on that pie slice or that diagram, and so one of them for a 1, a 2, or 3. The probability of a 4 is going to be given by 2 8s. Now again, if you don't cancel that down in an exam, I am led to believe the examiners will not be at all impressed, and you could actually lose the answer mark. When I went to a VCAA or meet the assessors, what they told me was, quote, they are not there to finish the question for you. So for example, if you write root 4 as your answer, they will mark that wrong. That seems unfair, and that's what I was told at that particular meet the assessors. You had to write that down as plus or minus, he says, plus or, let's try that one again. Plus or minus 2, and then choose the appropriate answer. All right, so just be very, very careful here that you are writing the correct thing. The probability in this situation of a 5 then would be 3 on 8, and that answers my question. It's looking again, can you see the differences? Which numbers are repeated? Complement versus complement. Now, it's taken a long time to ask this, but again, if you can subscribe to my YouTube channel, it is massive. It means the world to me, yeah? 10,000 subscribers today, I was stoked, yes? I almost had to lie down, but it has taken a long time, nearly 10 years to get that far. So if you can, it just means so much to me. Now, what is a compliment? Basically, as I say, it's when you write something nice and flattering on my YouTube channel. Thank you. This video was great, Darren. Or why are you really doing probability again? Please don't write that. All right, so if you can write that, but the one we are more interested in is in fact complement, or more importantly, complementary events. Yeah, so for something to be a complement, it's basically the inverse of or the opposite of, or it'll add up to 1. So in that situation, 2 events that could be complementary are raining and not raining. And again, we would normally use the word not to explain that. So our notation basically is that, and what I'm saying is you have PR of A with a dash. Now I can also say that as a PR with an A with a line on it is 1 minus the probability of A, and it's exactly the same here, 1 minus the probability of A. If I know what the probability of A is happening, I take it away from 1. Why? Absolutely, we can only have probabilities add up to 1, and I've said that below. So again, that's quite nice. A card is drawn from a random pack of 52 cards, or picked at random from a pack of 52 cards. What is the probability the card is not a heart? Now, this is causing life a little bit more, because a lot of you don't play cards anymore. You're all off there playing, I don't know, games on like Monopoly or Candy Crush or whatever else. So how many of you play cards? Well, there are 52 cards in the pack, and there are 4 suits. And there are hearts, there are diamonds, there are clubs, and there are spades. Now, hearts are red, and diamonds are red, clubs are black, and spades are black. And in that situation, there are obviously 13 of each card, because there's an equal number of each, right? So 52 cards, 4 lots of 13. And when you break each of those suits down, there are picture cards, which are king, queen, and jack. And then there are number cards, which is 10, 9, 8, 7, 6, 5, 4, 3, 2. And then there's this thing called the ace. And generally speaking, the jury is always out in my head whether an ace is a picture card or it is not a picture card. And generally speaking, I think the questions now have to tell you. So all you need to realize is that that also goes across. There are 13 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So there are 13 of those as hearts, 13 of those as diamonds, 13 of those as clubs, and 13 of those of spades. So knowing that then, what is the probability a card is not a heart? So basically not a heart. If I know then for part A, the probability of it being a heart is what? 13 out of 52, which is basically 1/4. So 1/4 of the cards are hearts. Then the probability of it not being a heart would be 1 minus the probability of being a heart, which is 1 minus 1/4, which would be 3/4. So 3/4 of the cards are in fact not a heart. What about not an ace? The probability, sorry, let's do that as a B. So B, probability not an ace. Well, how many cards in the pack are aces? Well, there's 1 heart, 1 diamond, 1 club, and 1 spade. So 4 of them. So I'm going to do 1 minus 4 on 52, which gives me what? Well, 4 on 52 would give me 48 on 52. So it's going to be 24 on 26 by halving them, and then 12 on 13. So there we go. So the probability of not being ace is going to be 12 on 13. And a random experiment may result in outcomes A, B, C, D, or E. Okay, so let's see how that goes. We've got outcomes as A, B, C, D, and E. What do we got here? Right, where A, B, C, D, and E are equally likely, and E is twice as likely as A. Right, well, we don't actually know the specific outcomes at the moment, but if we say that A, B, C, D are all X, they have an outcome of X, then E would have to be 2X, yeah, because E is twice as likely as A. What do we know about all of these things when they add together? Well, we get 1, 2, 3, 4, 5, 6 X's must equal 1, because all of those probabilities must equal 1. So therefore, X is equal to 1/6. So that's now 1/6, 1/6, 1/6, 1/6, and 2/6, he says, writing thirds, which is 1/3. Right, find probability of E. Well, therefore, then from this, the probability of getting an E is 2 on 6, or more importantly, 1/3. What is the probability of not getting a B? It's going to be 1 minus the probability of getting a B, which is 1 minus 1 on 6, which is lovely, 5 on 6. And knowing full well that my subtitles are going to be cutting through that, I'm going to lift it up. And believe it or not, that's the end of this video. I know. Fabulous, wasn't it? Yes? Hopefully. So, did we review everything? Did we know what an event was? A random experiment, sample space, equally likely outcomes, complementary events? Yes. Can I determine probabilities for equally likely outcomes? Yes. Do I know how to find the probability of event? Yes, I think I'm done. There are more videos coming in this probability series. Hopefully you will watch them. They're all, as I say, on mathsguru.com. There is my little corner of the internet. Hopefully I will see you there. If you can, subscribe to my YouTube channel. Tell your mates, tell your teachers that this resource is there and hopefully is really helpful. And I'll see you in another video. If not, you just take care and please stay safe.